Uh, Hello students, welcome once again. So we'll be continuing with the third chapter, that is metal and non-metals. So we have done the physical properties of metals. Now we'll be doing the chemical properties or the chemical characteristics of the metals. Now I have already told you in previous classes that there is a difference between physical properties and the chemical properties, right? So we'll be doing the chemical properties of metals today. All right. So the first chemical property of metal is number one. What happens when metals react with oxygen? Okay, so all the metals, they react with oxygen. Okay, most of the metals, in fact, most of the metals, they react with oxygen to form metal oxides. Alright, so what happens when metals reacts with oxygen? It forms metal oxides. Alright, let's see the example. When metal aluminium reacts with oxygen, it forms aluminium oxide. Alright, but this equation is not balanced. So all the equation needs to be balanced that we have done in chapter 1 in the classes, right? So let's balance it. So it'll be what, 3, oxygen is 3. Let's, if we write 2 here, 3 2s are 6. So 3 2s are 6. So aluminium will be 4. So it's balanced. Alright. So anyway, so let's come to the point. When aluminium metal reacts with oxygen, it forms aluminium oxide. Oxide of aluminium. Alright. Likewise, let's take another example. Copper reacts with oxygen to form copper oxide or cuprous oxide. You know what is cuprous and cupric, right? So it forms cupric oxide. So this will be the balanced equation. Alright. So when metal reacts with oxygen, it forms metal oxide. Alright. Now let's come to one of the point very important is metal oxides are always basic oxides. That means that metal oxides behaves like bases. Okay, that's why it is called basic oxides. Right? The nature of the metal oxide is basic. Alright. But there are always exceptions. There are some metal oxides which do not act as basic oxides. Alright, so these are zinc oxide and aluminium oxide. Okay, zinc oxide and aluminium oxide do not act like basic oxide. They are not like bases. Alright, so they have the characteristics of bases as well as acidic. Alright, that's why zinc oxide and aluminium oxides are called amphoteric oxides. Okay, amphoteric oxide means those metal oxide which has the characteristic of acid as well as base. That's why they are amphoteric oxide. Whereas all other metal oxide, they are basic in nature. That's why they are basic oxides. Clear? So this is very important. I have seen this question in CBSE many times. That's why you have to understand what is amphoteric oxide and the examples. Alright. Okay. Now next part in this portion is, like, see, all the metal oxides, okay, they are basic oxide. I told you they are base. Okay, and some of them, when we dissolve in water, they form alkali. They form alkali. Alkali is nothing but it is the base when dissolved in water. Alright, so most of the metal oxide, I told you they are basic, they are base. Okay, and most of the metal oxide do not dissolve in water. They do not dissolve in water. But if they dissolve in water, they become alkali. Is it clear? So let's take the example. The example of, let's say, sodium oxide reacts with water to form sodium hydroxide. So sodium oxide reacts with water. It dissolves in water to form sodium hydroxide. That's why sodium hydroxide, this is aqueous in the water. So this is alkali. Understood? So I'm telling you again, okay? All the metal oxide are basic in nature. Okay, most of them except this. Okay, they are base and they hardly dissolve in water, most of them. But when they dissolve in water, they become alkali. Okay, alkali is nothing but the base in water, in the aqueous solution. So we can say that all alkalis are bases, but all bases are not alkali. Is it clear? So all alkalis are bases because they are nothing but base in the water. So all alkalis are bases. Okay? But all the bases are not alkalis. So this is very important point you should understand in this part. Alright? Okay. So this is it. Now, the next point that we are going to do, the next character of chemical properties of metal, number 2. Okay, what happens when metal reacts with water? What happens when metal reacts with water? So when metal reacts with water, it forms the metal hydroxide, obviously metal hydroxide, and it produces hydrogen gas. This is very important. So when metal reacts with water, it forms metal hydroxide and hydrogen gas. And with some metal reacts with water to form metal oxide only, not metal hydroxide, and obviously it produces hydrogen gas. This is the second chemical property of metal. Alright, so metal reacts with water to form metal hydroxide, releasing hydrogen gas, or some of the metal reacts with water, okay, to form metal oxide, releasing obviously hydrogen gas. So I'll give you example. Let's take the example of potassium. Potassium reacts with water to give potassium hydroxide and hydrogen gas. Okay. Okay. So potassium reacts with water to give potassium hydroxide and it liberates hydrogen gas and it produces lots of heat. That's why it is exothermic reaction. You know what is exothermic reaction? We have done it in chapter 1. Okay, so this it produces lots of heat, but this is only in theory. Okay, but practically we cannot put water in potassium just like that, because potassium is very reactive. Even in normal temperature, normal room temperature, if you just take out potassium and sodium, obviously sodium, it reacts violently with the oxygen in the air. There'll be explosion. Okay, that's why sodium and potassium, that is the metal, is preserved under the kerosene, because with kerosene they do not react, but if you put it in water, there'll be what you call explosion. All right, so anyway, the next example is, like, let's take the example of aluminium. Aluminium reacts with water to form metal oxide, that is aluminium oxide again, and hydrogen gases evolved. Okay, and here the heat is not produced in a large amount. Okay, so even in, in order to aluminium to react with water, they need, even in cold water, they react. Understood? Okay, now next is, and it goes on like that. All right, like iron, they react with water to form iron oxide. You know that, what do you call that reaction? That is rusting, isn't it? So that is what happens to the iron. If you just leave the iron like that, you see rust. Okay, that is because iron reacts with water in the air to form that rust. Okay, iron oxide. Alright, so that is what happens when metal reacts with water. So when metal reacts with water, it forms metal hydroxide and it liberates hydrogen gas. Right? So this is the second chemical property. Alright, now the third chemical property of the metal is, what happens when metal reacts with acid. Okay, so metal reacts with acid to form its respective salt, and it also liberates hydrogen gas. Simple example is metal like zinc, granulated zinc, reacts with dilute hydrochloric acid to give salt, that is zinc chloride, and liberates hydrogen gas. So is it alright? So metal reacts with acid to give its respective salt and it liberates hydrogen gas. So metal reacts with any acid, okay, to give out hydrogen gas. But remember this, when metal reacts with nitric acid, HNO3. When metal reacts with nitric acid, it will not liberate hydrogen gas. Why? Because nitric acid is a strong oxidizing agent. Alright? So when metal reacts with nitric acid, okay, it forms salt, okay, and instead of hydrogen gas, they produce oxides of nitrogen. It could be nitrous oxide, nitrogen dioxide, okay, nitrous oxide, etc. plus water. Okay, hydrogen that is evolved is oxidized. Is it clear? So that is the difference. So metal reacts with acid, any acid, sulfuric acid, hydrochloric acid, to liberate hydrogen. Okay, but with nitric acid, metal do not liberate hydrogen gas. Why? Because nitric acid is a strong oxidizing agent. Alright, so that is it. Now the last part of this, okay, number 4 point, I think. Okay, number 4 chemical properties of the metal is what happens when metal reacts with another metal salt. Okay, let's take the example of copper. When copper reacts with silver nitrate. Okay, so when copper reacts with silver nitrate, metal reacts with metal salt. Silver is metal salt. What happens? What happens is the displacement reaction takes place. Copper displaces silver. So copper nitrate and silver is displaced. Okay? Is it clear? So, what happens when metal reacts with another metal salt? Okay, one of the metal displaces another metal. So, that depends upon the reactivity. Reactivity means different metal react differently with different substances. Like I told you, potassium and sodium, they react vigorously with oxygen and water and all. They are very reactive. Whereas copper is mild. And then if you go to aluminium and iron, they are less reactive than copper. And then if you go to gold and silver, they are not reactive. So different metals react to different substances differently. So we can say like potassium is more reactive than sodium. Sodium is more reactive than copper. Copper is more reactive than aluminium and iron and silver and gold. Okay, so if you see this, some metals are very reactive and some metals are not reactive. Maybe that's why, you know, the jewelries that we put on, it is made up of, if it is made up of silver and gold, okay, so if it is made up of silver and gold, it will be easier for us to like maintain that. Whereas if it is made up of other metals like iron, for example, there's chances of rusting. Alright, so different metals have different way of reacting with other substances. Alright, so these are the chemical properties of metals. Okay, chemical properties means how metal reacts with other substances and what are the products we get. So that is the chemical properties of metals. I hope you understood it. Alright, and one point you have to understand in this part is aqua regia. Now what is aqua regia? Okay, now if you mix hydrochloric acid and nitric acid in 3:1 proportion, okay, together, freshly prepared solution mixture, this is nothing but aqua regia. Okay, freshly prepared, you know, when you mix hydrochloric acid and nitric acid in 3:1 proportion, it is called aqua regia. And why I am telling you this is because I told you gold and silver, they are non-reactive. They hardly react with oxygen and water and all, isn't it? But if you put gold and silver in this solution, they get dissolved. Okay, so aqua regia, remember this. Aqua regia is very important. Alright, so we have finished the two parts in this chapter, that is physical and chemical properties of metal. Alright, and this is very important part. If you still don't understand, you can always call me or write to me in the group. Thank you very much.